So Felix is back with another talk. Last time it was a home computer, and this time is a small programming language for video games. If I understood correctly, he wants to write a coding game because when he needs a break from programming at work, he likes to go home and program some more. And honestly, I really hope he is going to be successful with his endeavors so that one day he'll be rich enough to really dedicate himself to his passion, programming. The talk is LoLa. When you don't trust the coder, you may be a game creator. So Felix, the stream is yours.
Hey, yeah, as Laura said, today I'm going to talk about LoLa, a programming language. It's quite small. It has, I think, 12 keywords. It's not your biggest language. It's maybe not the easiest language as well, but yeah, it's my own language. And the question is, why the heck would you create another programming language? There are so many out there, and yeah, I wanted to build a coding game. There are many games out there, like Else Heartbreak was the original inspiration, but also all the tech-like games like Shen.io or Exapunks are based on coding, and I really love these games. So I thought, let's do one yourself. And I checked out existing scripting languages like Lua or Python, and well, none of them really had my requirements fulfilled. So the question is, what requirements do you have to not be satisfied with the existing languages? Well, for one, the language should be simple to learn. So the players of the games are most likely not being programmers. So not only they have to learn a new game, so they also have to learn a new programming language. This is maybe the least hard requirement. Like Lua is really an easy scripting language, Python as well. So yeah, we could live with that. Another thing was scripts must have an execution quota. So if I'm going to run a process in a classic scripting language, it will run until the language returns. So if the player makes a mistake, like programming in an endless loop, we're having the problem, well, the script does not return ever. How do we solve this? And another thing is, we're building a game. So the player will press save, and also the scripting runtime should be snapshotted and serialized, so we can later restore it to a point where the player left off, which I think none of the programming languages I looked at had this feature. And the last one is it's a sandboxing requirement, which can be solved with a lot of programming languages. I think Lua doesn't guarantee sandbox safety. They go for more performance instead. And WebAssembly provides us with this, but we need a compiler as well for this. So yeah, these were the requirements. And I thought, hey, let's do your own programming language. You wanted to learn it anyways, so here we go. As previously said, my inspirations were Else Heartbreak with the programming language Sprack. It features interconnected systems in the game, so there are hundreds of computers running in parallel, executing scripts which you can modify. One example is your credit card is a computer you can program, which connects to the bank computer. And at some point in the game, you have infinite money because your credit card is always possible to use. It will accept any transfer of money. You will always have the same bank account, bank balance, because hey, I made it that way. The other games are like the Zectronics games. Here, TIS 100, Shen.io. Those games have this really nice property that you're given a goal, not like a way to reach it. So your classic computer game is you have to beat this way we made for you to reach your goal. And the Zectronics games are like, yeah, this is the goal, get there somehow, no matter how. And yeah, I both liked these games and I took inspiration from them. So yeah, enough introduction. Let's go to the first programming language example. Hello world. Well, looks like JavaScript to me. It's also a Java syntax highlighter. So getting more in depth with another better example maybe is this. We still have arrays like in JavaScript. We have a for each loop similar to JavaScript or C#. We have variable declarations. We have if. Yeah, it's nothing surprising here. The language is simple. The language was modeled after C# or JavaScript. And yeah. So how does the language work in practice? I'm going to do a little live demo now. Thanks to Zig, we can compile nearly all programs to WebAssembly and build our nice little playgrounds on the web. So yeah, this is my playground. You can choose an example on the right. You have validate, which compiles the program and checks if there are syntax errors, and you can press run and execute the hello world. Yeah, it's nothing special. We can do also by, and I made a typo, and we get here, there's invalid byte sequence. The exclamation mark is not a valid token. So yeah, we can play around here. You can find this playground on my website. Where is it? It's lola.random-projects.net. There's the documentation online. There are infos about the community. There's my currently failing builds. The GitHub repo is linked. So yeah, you can find all information you want on this website. Another example is what I was talking about earlier is the quantized execution. So I have an endless loop, and I can press run, and the code will run. And I can press stop anytime without multi-threading or exceptions or whatever, and I can just stop the execution again. This is a really useful property, so you can just run your script for like 1,000 instructions or slices, and the script will return, and you can continue later. And here is a more complex example where I can talk about semantics of the language. I've implemented a wonderful function called bubble sort, which most of you should know already how to implement it. So when you run it, it will sort a list of numbers, and it will sort a list of strings. And the language has no reference semantics. So we have to put an array input into the function, and the function will return a new array. So this array we're passing in is getting copied, not referenced. So yeah, we're creating a copy of the array, we're determining the length, we're executing bubble sort, and we're returning the array again. Nothing special, it's all plain and simple. The function, the language also has stack traces and panics. So when we run this code, it will panic at the function boom here. And we can see if we call within, it will call deeply, it will call nested, and nested will call boom. This will fail, and we get a nice stack trace. So debugging tools are there as well. And one feature of the language, which is unusual for scripting languages without static typing, is that the language actually has a type checker. So there is no coercion between types. So I'm assigning a string here, and I'm adding 10, which is not a string, so it will type error at runtime. And the nice thing is I can press validate here, and it will tell me in line 2, I cannot add the 10 to string because string is a string variable, which is here, and 10 is a number, and those are not compatible at this point. We can change this, though, by using an assignment of a number. which will now allow in the type checker that string might be a number, so this code might be okay. It's very conservative and will only give you errors or warnings when a type error must happen at runtime, not if it might happen. Yeah. Okay. So yeah, the language design was a recognizable syntax. As you've seen, it's really C-like or C#-like. There are no reference semantics, as told. There are also no objects like the hash maps we see in Lua or JavaScript or Python. The language scope is quite small, and I don't think it needs these objects. It would be possible to implement them. I'm open for a proposal as well, so they might come. Yeah. And it's also shown that the compiler can detect guaranteed type mismatches and print a warning. So yeah, the simple to learn requirement is met, in my opinion. It's an easy language, it's documented, it has examples. With everything we need to learn the new language anew. So for the next point, we need to have this quota to limit execution. And at first, I implemented the language or the language runtime as an AST interpreter. And I noticed that as soon as I'm in a loop, I cannot break out of the loop without returning in again later. So this wasn't the best idea. So I went the way all script languages work. I've gone with a bytecode. And the virtual machine, you can just say, hey, run up to 20,000 bytecode instructions and return back. And you can resume that state later at any point. And as it's meant for game scripting, we also have like long-running functions. Like we have a function which is the simplest is sleep for 10 seconds. We don't want our game to like freeze for 10 seconds when a script calls these. So we have asynchronous functions which immediately yield control back to the host of the script. And you can return later to check if the asynchronous function already completed or if you have to wait more. So here's an example of the bytecode for a very simple program. It's a stack machine, so we have push instructions, we have store instructions with global variables, we have call instructions. It's the usual thing. All the instructions are documented and should be self-explanatory if you've read the documentation, I hope. So yeah, next point is also successfully fulfilled. We can execute only pieces of the code and pause at any time. This wasn't also the hardest part in the language, but the next one will be its serialization. Serializing a script language at any time in the execution wasn't trivial. I had to think a lot about how to implement it, how you can recover any state later. And I have to admit, it's not fully implemented yet. Asynchronous functions calls cannot be serialized at the moment, but I have a plan for this, and I just haven't had the time to implement it. Yeah, the runtime is fully serializable. You can pause the execution at any time, send the state over the network to another computer, and resume execution there. The language, as said, has no reference types, which makes serialization really easy. You just dump all your values into the stream, and you can restore them later without having to resolve loops in the type structure. But it's only for the value serialization. The serialization of the whole state of the virtual machine wasn't that easy. Oh, also here, a live demo. I have prepared a small script which is divided in 3 parts. We have one part that has an allocator and runs some code, so compiles some code, runs it, serializes it into this buffer. Then we print a nice divider to see where our upper part and lower part are running. And we deserialize that buffer again. So the only interface between this code and this code is this buffer. So a flat buffer without any addresses in it or something. So just serialized data. And the code we're executing is a simple for loop from 1 to 100, printing each round we're in. And when we run this, we can see we successfully printed up to 100 elements, starting at 1. And we can see in the middle of it, we're suspending at offset 29, that's the bytecode offset, which is line 1. So we're in the for loop implementation above here. It took 1006 bytes to serialize the whole state. And we're restoring those bytes again, resuming at the same position, and just let the code continue. I think this is one of the most unique properties of LoLa, that you can serialize at any point and you're safe to resume the code later. Yeah, next part of the requirement list is also fulfilled. Wonderful, one left. And this is where Zig really helped me in implementing, because first I can use an allocator with a memory quota. So let's say this allocator is allowed to allocate up to 1 GB of RAM. And if it goes above, it will just out of memory and the execution will fail. So I can safely check if scripts are using too much memory or not. I can catch endless loops by just using the quota. So the script will just return after 20,000 instructions, and the endless loop will not halt my program. This is also nice. When something bad happens in the script, I'm getting a LoLa panic. So the script will just error out and say, hey, I'm broken. Please recover my state and resume me later or whatever. And LoLa panics are implemented as Zig errors that bubble up to the host, which is convenient. The same for host functions. So when a host function errors, it will also just bubble up the error through the virtual machine to the calling host or to the embedding host, and we can safely see that our script crashed, so no runtime crashes at all, which are not recoverable as for the host. So our games will not crash in any cases when the script goes wild. And also here a little live demo, which isn't that as exciting. I've looked up some implementations of in-browser scripting languages. One is Fangario. It's Lua in the browser, and when I'm typing a simple endless loop, which does nothing, I can make it big, and I press enter, the site is frozen. I cannot interact with it anymore. It's broken. That's not the state that we want. It's inconvenience for the user. It might use up battery life. It's not good. The same happens for JavaScript. I have no idea why this returns, but the site is now also in a kind of inoperable state. So you can see it doesn't work anymore. This JavaScript is frozen. We cannot resume. We cannot use it anymore. And let's hope this will close. No. When we do the same thing in LoLa, it will just work. We can use the site, and we can press stop at any time, resume the code, putting a thing here in, print, loop, whatever, and let it run. and the site will still work. We have no problems in using it. So yeah. Last requirement is fulfilled. We have now a language that is easy to learn, which is executable in quantized pieces, so our programs will never freeze. We can serialize every program running at any time, and the user cannot break our host, which is also a nice property. Yeah. And for those who want to use the language, I'm now going to explain a bit how the API works. This is a basic program showing us how to use LoLa. Most languages have these 20 lines of code as a single line. So there's the Lua do-file or do-string API, which compiles and executes a piece of code. But LoLa is about having control over your execution. So I've split that up into host API as well. The first part above here is a call to the compiler, which requires an allocator to create our compile unit, which has a set of diagnostic messages. These are the messages we're seeing not here. We're seeing down. We're seeing here. These are diagnostic messages. We have errors and warnings. If we successfully compiled our code, which is this, we need another thing to get running, which is an object pool. LoLa itself has objects in the language, which are opaque to the user. So having an object is, I think I have enabled it, I'm not sure. No, I have not enabled it in the runtime of the website. So you can create objects, which are opaque pointers, which have methods you can call. So this is everything you can do with an object. You can compare objects and you can call methods on them. The point is objects are garbage collected. So I can do list2 and list, and this is actually a reference. So this is a reference to host objects, and this needs garbage collection. And for this garbage collection, we need an object pool. The object pool provides serialization for the objects. It provides deserialization. It provides memory management. So it allocates or deallocates the objects. With a compile unit and an object pool, we can initialize an environment. The environment will contain all global variables and is like your process of execution. So in classic OS, this would be the process, and we can install functions into the process. Here I'm installing the whole standard library, which contains stuff like substring, length of an array, and so on. And to actually run code, we need to initialize a virtual machine. This takes an environment and will run the code in the environment. So a virtual machine in LoLa is a thread in classic operating systems. And we can now execute the virtual machine for 150 instructions. If we're not interested in having quantized execution, we can just pass null here and get infinite execution until the script either errors, is completed, or will suspend because of an async function. And we're getting a result which tells us what happens and why the virtual machine returned. Yeah, this is just for people that watch the slides later. Explains the stuff I just talked about. Yeah, so maybe LoLa can be your next best programming language. Maybe you're building games with it, maybe not. You have total control over the execution and the environment. You can hack into any piece of the language and change stuff of the execution. Everything is serializable, which is also a nice property. Yeah. So thank you. This is it.
Thank you very much, Felix. Wow. So let's move into the Q&A. Let's give it a few. Let's give a moment for the chat to come up with questions. And there's Matt clapping in chat, by the way. So we have actually one question already that Sobson had earlier, and I think it's a very appropriate question. So it's about the logo, the character, right? The mascot. Is she your waifu?
Nah, it's like a personification of the language itself, but no, it's not my waifu.
Okay. I am forced to report all questions that the audience is asking. So, so that was nice. I think that you made a very, very strong case for having having those features that seem like, after your presentation, they seem fundamental. I don't see how anybody could do without those features. It also, it kind of made me wonder. There are some games like that have Lua scripting, right? I'm thinking about Skyrim. I might be wrong. It might not be Lua. I haven't done it myself, but there are plenty of games that, for example, have Lua scripting, and mods use Lua scripts to do stuff, and mods also have weird interactions with one another, crash the game, and everything else. I think that's an interesting argument for maybe not every game. Maybe some games need the extra performance that Lua provides, as you said earlier. But maybe some of those games, even if it's not just for the end user, like for the player to program with, even for modding could be interesting. What do you think about this?
Yes, actually, this is true. And I think the language is also quite well suited for the general in-game scripting. So like programming how your NPCs should work or talk and creating, the top-level game logic. The language itself is also suitable to build stuff like the RPG Maker series programs.
Right.
Where you have also these super asynchronous scripts where a function call could take like months when the player is just sleeping in front of their PC. And as you mentioned, Lua, there is actually a way in Lua to create like this quantized execution, but it's horribly slow because you have to check into the debugger and like count in Lua every time when an instruction was executed, which is not very performant. But it's the only way to get, to my knowledge, to get this paused execution thingy.
Mm-hmm. Yeah, let me think. Another question. Well, let's see what the chat has. So there's a question from Nipsey. What was the biggest hurdle to overcome during the implementation of LoLa?
I think the biggest hurdle was actually the whole serialization thing, where I think I needed 2 weeks to figure it out how to do it properly. And even then, the implementation was not straightforward.
Mm-hmm. Another question. What garbage collection method does the LoLa runtime have use?
It's a manual mark and sweep algorithm. You have to call some methods on the object pool, which is shared among all environments and virtual machines. So you can even have across objects in multiple virtual environments at the same time without interfering each other. And it's basically a mark and sweep garbage collector, which should be called sometimes.
Mm-hmm.
Yeah.
Okay, another question from a rude dev. Can you talk about parsing a bit? he also continues, I've never written a parser, and I'm curious about what type you chose and why.
Oh yeah, I've actually rewritten the LoLa 3 times by now. It's my third attempt. First was in C# with a Bison variant, so a parser generator. The same with the next generation, which was the C++ implementation, which also had the parser generated parsing. And the Zig version now uses recursive decent parser, completely self-written. And I can show some of the code.
Sure. Let me bring up the view.
Yeah.
Yep.
Let's close the terminal. The parser for the whole language is 1,700 lines of code, which with a lot of testing. And if I'm talking a lot, I'm talking a lot. So without tests, the parser is 800 lines of code. The parser is recoverable. So if I'm doing stuff wrong, I can open a block and I can forget to call a function, whatever, and do the same thing here. And if I'm validating, can actually detect syntax errors here and there. So in both places. Parser is recursive decent, which is basically a lot of those except functions. And the top level is, I think, except statement. This is the top level function for statements, which this is a statement or an assignment is a statement. And I have a parser state, which I can restore later. So when anything errors in except statement, I can jump back to the place in the parsing before I changed anything in here. And I'm checking out here. It's basically switches and those except functions, which check for token types and return the appropriate stuff in the AST. And the parser itself outputs a syntax tree, which is a list of statements on the top level. So if I'm doing this, this will be a node in the root script. And if I'm doing a function, this will create an entry in the functions table. And functions are just statement lists with a parameter list. And the AST is implemented as 2 tagged unions, one for the statements and one for the expressions. Yeah. I hope that answered your question. If not, feel free to come back later at me and just ask me.
Awesome. Yeah, I think you were very thorough with your answer. Let's see. Oh, I have another question. Do you have any like CABI bindings? Do you plan to write some? Any problem? Because I expect like game developers, like if you want to attract game developers, they will probably have their C++ game already written, and maybe they will think of, let's see how hard is it to adopt your language. So what's the state?
Right now, I only have a GitHub issue which says, please design a CABI compatible interface. But yes, I'm planning to implement this and provide a CABI or C API for the language itself, because as you've said, there are a lot of C or C++ programmers which would also benefit from having this language available.
Yeah, I'm also thinking that once you have CABI, you also get stuff like Unity, right? Because they will be able to use your stuff from C#.
Yeah, exactly. So you can import the binding in C# and use it from there, or you can use it on Android or whatever platform.
Right. I would not want to code on Android, but I get your point. It's also for the game mechanics itself.
Yeah.
Okay, that's actually really awesome. Thank you very much, Felix. I don't think there are other questions. Let me take a peek at other places, but I think we should be actually no. Let me double check here. I think we should be good. Yes. Is there anything that you want to say before we move forward?
No, just thank you for having me, and I'm looking forward for my next talk.
Oh yeah, next talk is gonna be a t-shirt, right? Yeah.
Yeah.
It's a shame that Benjamin, he was so close, and then I don't know what happened. That guy. Anyway, thank you very much, Felix. So
Yeah.
let's move to the break.